Introducing Functions, Lesson 12 Notes. Example number 3. Determine if the relations represented by the graphs below are functions. So again, I'm going to use my vertical line here. So as I drag my vertical line across the graph, and let me actually zoom in a little bit. There we go. As I drag my line across the graph, does it ever go through more than one point? Right there it does. Notice on the y-axis, it goes through a point right here, and it goes through a point right there. Therefore, this graph does not pass the vertical line test. So let's go ahead and circle those 2 points. Because it doesn't pass the vertical line test, this is not a function. It does not pass the vertical line test, therefore, not a function. Let's look at example 3b. At any point, does this go through more than one point on the graph? No, it does not. Because it doesn't go through more than one point, this would pass the vertical line test, which means this is a function. Well, let's take a look at some other types of graphs. Okay, I know they're not perfect, but you get the point. Let's just take a look at these. Number 1, as I drag my vertical line across it, does it ever go through more than one point? No, it doesn't. So number 1 is a function. I'm just going to put an F. Number 2, it might go through only one point here, but as soon as I move it here, there's multiple places where it goes through more than one point. Therefore, this is not a function. Number 3, does it ever go through more than one point on the graph? No, it doesn't. So this is a function. Number 4. Again, it might go through one point there, but as soon as I get over here, here, a bunch of different places here, it goes through more than one point. Therefore, not a function. So if you can't tell, it goes through right here, and it goes through right there. Since it intersects the graph in more than one spot, it would fail the vertical line test. Number 5. If I stop this right here, it goes through the graph here, here, and here. So it goes through the graph in more than one spot, making this not a function. The last one. Now the last one you're going to have to remember when you used to graph numbers on a number line, the difference between a closed-in circle and an open circle. If I put a vertical line here, it goes through this point here and this point here, making this not a function. However, the reason why this isn't a function is that if you remember way back when you graphed on a number line, if I had the x is greater than or equal to 3, because it's greater than or equal to, that means 3 is included. So you would put a closed-in circle, and you would draw an arrow going in a certain direction. Because the 3 was included, it's a closed-in circle. However, what if you had a problem that looked like this, where we have open circles? Well, this is like when you used to graph x is just greater than 3. In other words, the 3 is not included. So you would have an open circle at 3 and then your arrow. The open circle means that the graph does not actually, isn't actually at the point 3. It's real close to it, but not at actual 3. So when you see these open circles on this graph, if I put my vertical line, because those points are open, that means it's not going through 2 points at once. Therefore, this would remain a function. Even if one of the circles were closed, even if this circle was closed, because the other one would be open, it would still be a function. Okay, so let's go back to the notes. Let's skip down to number 5. Let's determine if this relation is a function or not. So I'll grab my vertical line. As I drag this vertical line across, at any point, does it go through the graph in more than one spot? No, it does not. Therefore, it is a function because it passes the vertical line test. Pause your video and write that down. All right, if you have any questions on examples 3 or 5, please let me know. Make sure you have everything written down. Again, if you have any questions, please let me know.